Good morning, everyone. My name is Kira Proctor, and I'm the Managing Director of the A Proctor Group, and welcome to our 14th webinar of 2021. We've been running these since April last year, and if you've missed any, you can go back and view the full series on demand whenever suits you. You can find them right here on our YouTube channel or through our Learning Hub at www.proctorgroup.com, where you can also request product information and samples, or book in for a follow-up meeting with one of our team of experts. Remember, you can also register for CPD certification for today's presentation using the link in the chat. This morning, we are once again joined by a very special guest presenter, David Somervell, Secretary of the community-led organisation CHOISS, Cohousing in Southern Scotland, and advisor on sustainable architecture. David will be talking through the principles of co-housing and discussing how social and technical factors can be combined to deliver sustainable communities and build towards a net zero future. After that, we'll follow up with a brief introduction into the effects of insulation placement on the hydrothermal characteristics of high-performance fabric envelopes, and take a look at how this affects design for both refurbishment and new build structures. We'll then finish as usual with our Q&A session, where David will be joined by our panel of technical experts to take your questions. I'll now pass over to David to begin today's webinar.
Greetings, friends. It's so nice to join you this morning to have this informal conversation about net zero communities. My name's David Somervell, and I've been asked to just introduce some of these ideas. I've got 3 points I'm going to be making today, particularly looking at co-housing as one form of intentional community, some principles of sustainable communities or unsustainable communities, and finish off with some reflections on appropriate materials before I look at a case study. I'm going to show you now a short clip, 2 minutes, about a co-housing setup in Leeds.
Co-housing is an approach to building neighbourhoods in a way that really promotes community. It's not a commune, and everyone gets to choose how much they want to interact with their community. So we've all got our own front door, we've all got our own house or flat, with its own kitchen and bathroom and everything. It's designed so that it promotes community, but there are also economies of scale that you can achieve as well. So we've got things like, we've got a shared laundry, so we don't all need to have a washing machine. We've got a workshop where we've got one set of power tools, so we don't need to have 20 drills on site. We've got lots of space here, so there's kind of shared community gardens. We've got a common house, which is a great facility and we can use to sit down and have dinner together. This is the entrance hall. Through here we've got the dining room. So we've got seating for about 30 to 40 people in here. 3 times a week we'll have a meal, which is not compulsory. A very common feature with co-housing is that all the car parking is right at the periphery of the site. So that means that you haven't got lots of noisy traffic coming through, it's safer for the kids to play. The kitchen windows all overlook the communal space, so people can be doing the washing up and, oh, hello, you can see each other through the window and that kind of thing. So it kind of promotes community, but it doesn't enforce it. It means that you get all the benefits of community without some of the downsides. You definitely have a closer relationship with your neighbours than you would in most other neighbourhoods, because you've got to manage those communal assets. But yeah, that's great because you just really build up these really strong local communities. Often they're community-led, so in this case we kind of all came together, stumped up the cash, also got a loan, and developed it. So we were the kind of the property developer in this case. So we kind of designed it how we wanted it. We've also got an affordability model that means that it's more financially accessible for members as well. So there's often an additional ethos behind co-housing, and a lot of them tend to be quite environmentally conscious.
So the basic principles of co-housing design are the idea that every household has their own key, their own front door, and they're generally ranged around a common house, some sort of common facilities, and they're designed and managed and run by those residents. I'm going to show a few pictures of different communities in different parts of the world, but I'll start with one older women's co-housing, Ouch community in Barnet in North London. You can see here the common house in the corner, just near the entrance where you come into the site, and then in 2 arms facing southwest onto a central garden, you have a range of flats and accommodation that in this case, women over 50 elected to be residents for. In another case here, we've got a more rural layout where the parking is all kept right to the edge of the site. A common house, first thing you come upon coming into the site, and then individual dwellings ranged around in groups, in this case in 3 groups, around a common area in this lovely extensive landscape that this particular co-housing group is in. Here's photographs of older women's co-housing, new ground co-housing for senior members, very attractive balconies, lots of balconies, so even if you're on an upper floor, you have access to outside. In this case, a rural one in Dorset, all the dwellings face onto a horseshoe-shaped common garden. In the case of the Leeds example, low-impact living, affordable communities, the common house is in the middle, and then ranged around it and around this sustainable urban drainage system, pond is the accommodation. In the case of Forge Bank or Lancaster co-housing, they look south, long terraces looking south onto the River Lune. In this case here, the community themselves have tapped the energy from the original mill building, had a mill race, and there is just further up, a little further upstream, there's a hydropower scheme which provides renewable electricity onto the site. Another mill-based mechanic mill in Colchester. Here, the mill pond is just to the right of this photograph, and the dwellings are built up on the hill, and the mill building itself forms the common house. In other instances, the conversion of and modification of long-standing dwellings which are too big now just for one family. Here's an example of the common house from about 15 years ago now in southwest England. In this case here, the common house is quite an extensive building for about 30 families living around it. A more modest room with kitchen and dining room. There's a laundry to the one side in the case of Lilac, and then a meeting room and so on upstairs so that there's common spaces where people can meet. In the case of Lancaster co-housing, it's got kitchen, dining and leisure areas. And in some cases, upstairs they'll have some guest bedrooms so that it's not necessary for every dwelling to have an extra bedroom. Now, these are all about people. In this case, from Seattle, intergenerational co-housing community. In this case, it's in Boston, Massachusetts. And we've got examples from other countries as well. In Australia, people enjoying the company, but always having their own private space as well. And here's an example, a conversion of an older building in Hungary with a young group, multi-generational, coming together. Closer to home, this is Marmalade Lane. This is a home zone, a street, but a pedestrian street in a new set of buildings of 40 dwellings in northwest Cambridge, where town as developers have worked with the council and with a Cambridge co-housing to develop new dwellings. Designing for life is, of course, one of the crucial things. I've talked about intergenerational, but too many of our homes are not appropriate for us when we're getting older, and not flexible enough to be able to adjust to different family size over the course of a lifetime. And so this is one of the principles. And one of the other major principles underpinning all of these is the absolute desire of those coming together to explore co-housing opportunities to look for very low energy buildings. In this case, passive house, or if it's a refurbishment using the Enerfit standard. Here we've got cross-laminated timber construction being used. In the case of Lilac and Leeds, used a cassette of off-site construction using straw bales modified. And in the case here of this last one, the new building and timber and an existing building. continuous insulation wrapping the building is absolutely crucial to reduce the thermal bridges and risk of dampness and cold bridging. Building tight and ventilating right is a mantra, along with the mantra of fabric first, that I remember even from my architecture school 30, 40 years ago. So these are very important principles which actually still have not really been widespread adopted, and we should be. Now, this is not rocket science. This is not totally new. A slew of guidance and assistance and help. This is these 4 guides, a range of publications from the Federation of Intentional Communities in the United States. And this is a book about eco-villages, which is the next scale up, or maybe sometimes slightly larger groups of intentional communities being built. In the UK, we're very lucky to have community-led homes in England and Wales, and UK Co-housing Network. This massive guide is available to all members of that network, and an earlier guide from the North America, the handbook. Now, I've talked about and introduced the ideas of co-housing. What I want to also now just talk about is probably what's not sustainable. What's not sustainable is sprawl. This is urban sprawl, tarmac covering the plains in North America, and lot housing, single-family dwellings spread over huge areas. Massive problems for when you have deluge rain because so much hard standing, but mainly it's to do with access and availability, and anomie, loss of community. And this is writ large in the developing world as well. Here is Shanghai and China, huge problem where following American and the West's lead, they've urbanized extremely rapidly, building high, but very dependent on the motor car. To counter this, Anne Hidalgo, a few years ago, coined this concept of the 15-minute neighborhood in Paris, as mayor of Paris. And in Scotland, our local authority, City of Edinburgh Council, just last month adopted a 20-minute neighbourhood approach to complement their own moves to a net zero by 2030. This has got a number of features. I won't go through them all, but I think it's hugely important to recognise the value of neighbourliness. And this is to do with a different form of intentional community. It's to do with planning, not necessarily letting the market decide everything, and to identify promoting well-being as a greater importance than lots of little boxes on the fields around Edinburgh. Now, all of this is within the context of the climate emergency. You may be surprised to know that 3/4, a full 74% of all councils in the United Kingdom have declared a climate emergency. In the case of Edinburgh, it was 7th of February 2019, so some time ago now, and they've eventually got around to publishing a draft climate strategy to see how we might achieve this dramatic reduction in emissions associated with the city of Edinburgh. That's definitely the context. As the next point that I'm going to be touching on is to do with building materials and their role in them. Now, I confess I've got previous with Proctor. In the late 70s, early 80s, we moved house into a double upper flat on the Tollcross in Edinburgh. And the coombs, the sloping wall on the flat roof of this tenement, totally uninsulated. It was Baltic. It was really cold. And we realized we had to do something about this. So we rootled around and researched as best we could, and found out about Proctor's use of Dow Chemicals styrofoam composite with plasterboard. In those years, it was a pale blue color, the foam insulant, but we got sheets and sheets of this and got plasterers make nice plastered internally. We just mechanically fixed these to the thing and skimmed internally. Those rooms hardly needed any heating. It was just wonderful 40 years ago. But in the ensuing years, I've actually recognized there's also something to think about the materials that we use and we have around us all the time. Because we live so much of our time indoors, we need to be very careful and thoughtful about what we're doing. And this building biology, as it's called, started in Switzerland and it's got many adherents in Northern Europe. But it's essential for us to think about how we can get the balance between efficiency of things and ecological balance. And there are 25 principles that are really, really helpful. And I'm sure that if you're wanting to follow that up, you'll be able to. Thermal and acoustic comfort, human-based designs, not necessarily working to minimum size of windows to have enough daylight coming in, which can actually often have a benefit from reducing the need for artificial lighting and so on. Most important, obviously, is energy consumption and using renewable energy. All of these things. There is a social component as well, and this is often forgotten. So in the same way that we can obsess about carbon, and this net zero stuff is a bit of an obsession with carbon, we need to also acknowledge the nature emergency or the ecological emergency that is happening at the same time around us. Now, it's because there's a recognition of not only the energy and carbon associated with buildings in use, but also the embodied energy. I'm just going to show you a short clip slide here, 2 minutes from the World Green Building Council about embodied energy.
We are in a climate emergency. The IPCC special report warns that all sectors must eliminate their reliance on fossil fuels in order to limit global warming to 1.5 degrees Celsius. The building and construction sector has a vital role to play, as it's responsible for 39% of global carbon emissions. The majority of these emissions occur when a building is in operation, from energy used to heat, cool and power them, but a significant amount also comes from embodied carbon, emissions as a result of material manufacturing and construction processes, building maintenance and renovation, and when buildings are demolished. In the next 30 years, global building stock is expected to almost double, so we must act now to reduce upfront carbon, the emissions generated before new buildings are used. Our vision is for all buildings and infrastructure to be net zero emissions across their entire life cycle by 2050. This means that by 2030, along with zero operating emissions, new buildings and infrastructure must have at least 40% less embodied carbon, with significant upfront carbon reduction. And by 2050, new buildings and infrastructure must have 100% net zero embodied carbon. Achieving this vision will require global collaboration across sectors and leadership on the following actions: roadmaps to educate, communicate and innovate towards decarbonisation solutions, ambitious public procurement policies and embodied carbon reduction targets from governments and cities, innovative financial products and services to trigger market demand, clean and lean construction processes, products produced by renewable energy, designers specifying low-carbon products and design solutions, buildings designed to maximise reuse, refurbishment and deconstruction. The market transformation needed requires a radical change in the way we design, build, operate and deconstruct our buildings to conserve the world's precious resources.
And this brings me full circle around to a little case study that I can share with you to finish off my presentation. This is about 20 households who came together virtually online this January when we heard that Comiston Farmhouse was again being marketed and put on the market by the City Council. A former children's home in south of Edinburgh, in the southern suburbs, on the hill as you go south towards Biggar and Carlisle. It's in the midst of what's now an early sprawl, but it's still very much within the city boundaries of semi-detached houses and bungalows in the neighbourhood. And we have here an acre of land in a walled garden around the original farmhouse. It used to farm the land on which these houses have been built in the 50s and 60s. And so it's a well-kent landmark, got cultural heritage, importance, and so on. Here's the acre of land, the 4-square farmhouse in the middle. Originally, this would have been the back garden or the kitchen garden, which would have fed the house, and there would have been greenhouses on the north wall there. It was closed as a children's home in 2015 and put up for sale. And the original bidders appointed planned to knock the the building down and build 37 flats, high-rise flats like these ones, a bit lower down the hill here. The neighbours went ape, and it was very, very unusual that the planning committee decided to vote against it after this very, very successful campaign to save Coniston Farmhouse. So we came along after a further upset with the sales, envisioned how could we convert this farmhouse to a community use and to establish an intentional community beside it. And we've got these 5 principles co-designed with members of the community, the residents who are going to be living there. Private homes, it's not a commune as the guy from Lilac said at the very beginning. We would have probably had between 10 and 15 households at Coniston. The idea of resident control. It's not a developer, it's not McCarthy and Stone, it's not Wimpy deciding what the buildings are going to be like, it's residents themselves. And most importantly, it's part of a diverse, wider community. So here's the site, and we originally envisaged just a terrace of narrow frontage homes on the back green. But until we found that there was a culvert or a stream in a pipe running about 4 meters underneath the back garden, and it would have cost an awful lot to have diverted it round. I think this was one of the upsets from a previous developer. So our architect designed it so that it, working with what we had, a simple terrace of 2 terraces of houses. Here's the existing quite generous sized farmhouse. The big reception rooms would be using as dining rooms and could be cleared and used as a film. You could watch films there or have a ceilidh and a living space. And then upstairs, a couple of flats either side of the main corridor. And the L shape of the terrace of the new build at the back, very well insulated. And this is what I'm now going to touch on. What should we build it of? Nearly everybody, even though they were lay people, were really excited about the idea of exploring seriously the concept of cross-laminated timber or mass timber. The reason is practical. It's a very quick way of off-site construction, but also it can sequester carbon in its construction, which we just heard about from the Green Building Council. Looking at the insulation, we've then been exploring an innovative Scottish initiative, Indie Nature, based at Edinburgh Climate Change Institute, where they've developed a new concept of growing hemp, which is about 6 foot high, plant grows seasonally, lots of fibrous material, which can be made into benign bats and boards. And so in this case, the growing absorbs carbon dioxide, and independent researchers have estimated between 4 and 5 tons of carbon is saved per average home. So this is good for nature, good for people. The people is the important thing. And so I'm going to end off with some nice comments from the largest co-housing community now being constructed in Dorset on the south coast of England.
Co-housing is
sharing,
friends,
being more environmentally aware,
community,
Hooray! Hooray!
connecting,
caring,
growing together,
reassuring in complex world.
Co-housing for us means security, living with neighbours who we know will look out for each other.
My daughter and other people's children can grow up with lots of other adults and people looking out for them.
What are you looking forward to?
It gives us a chance to possibly own our own house. I am looking forward to not having to worry about if my landlord is going to serve me notice every 8 weeks.
It will be such a relief to have a house that we can actually afford to live in.
Having a modern, eco-friendly homes.
It will be possible to share all sorts of things, such as transport, food growing.
We can have smaller houses because we've got big shared facilities. We've got the open fields, we've got the guest rooms, and we've got the common house.
We need somewhere to eat. I need somewhere to run and be myself. I hope we can do camping in the field.
It gets harder and harder to prepare and enjoy good food just for myself. The common house will give me a place to go and cook and share food with friends and neighbours.
All ages, all backgrounds. This common house is absolutely core to what our co-housing project is all about.
It's the heart of the community.
Lastly, this session is being called Net Zero Communities. I just counsel that net zero is not zero, and we need to be very careful about using this term and not let the corporations, the oil companies, and so on, pull the wool over our eyes when they talk about we're going to be a net zero corporation by 2050. Because if they rely entirely on offsetting, it's going to be problems. Thank you.
Many thanks to David, and we'll pick up with him shortly for the Q&A session. Before that though, we'll take a brief look at the hydrothermal issues around structures with very high thermal performance. Although super-insulated buildings are nothing especially new, as we move towards net zero, very highly insulated thermal envelopes are becoming far more common. Whether the project is new build or retrofit, adding a lot of thermal resistance to a structure necessitates careful consideration of the effects on moisture movement. If the vapour transfer properties of the envelope are not equally well considered, high levels of thermal insulation and airtightness can give rise to all manner of moisture problems. So, let's quickly recap on how condensation problems originate in the building fabric. As we move outwards through the building envelope, the temperature will drop according to the thermal properties of the various layers within the building fabric. Alongside this temperature gradient, we can also calculate the dew point at any given position. This is the temperature at which air becomes saturate and loses its ability to transport moisture vapour. Once this dew point temperature is reached, the airborne moisture vapour turns into liquid water and can lead to interstitial condensation if not carefully managed. Understanding how these two temperature gradient lines are influenced by the properties and positions of the materials used is the key to a robust and healthy building envelope. To illustrate this, we'll consider two basic wall constructions: an existing solid stone wall commonly found in refurbishment projects, and a more modern cross-laminated timber panel wall. CLT panels are finding increasing use in passive and low-energy new builds, where the combination of sustainable low-wastage off-site manufacture and flexible design options are particularly useful. In each case, we will look at how the hydrothermal situation varies, whether insulation is placed internally or externally. We'll also consider how the thermal and vapour transfer properties affect the relative positions of the temperature and dew point graphs within the wall. In a cross-laminated timber panel, the most common configuration is to place the insulation and any associated construction membrane on the outside of the timber structural panels. Shown here is a typical build-up using our wrap-tight air barrier, adhered to the CLT to provide the airtight line, a fibrous type insulation, our fire shield vapour permeable membrane, and finally, a timber cladding system with a fully ventilated void behind. In this construction, the vapour resistance decreases fairly consistently as we move outwards towards the construction, so the dew point and temperature gradients remain well separated, meaning there is little or no risk of condensation occurring under normal circumstances. In fact, because the vapour resistance on the warm side is sufficiently high relative to that on the cold side, the specification of the insulation can be varied with little chance of introducing a condensation risk. This is because the moisture vapour can escape the element before it cools enough that it condenses. If we vary the thermal and vapour resistance characteristics of the insulation, it will affect the relative positions of the temperature and end dew point lines, but the temperature will not reach the dew point. This makes externally insulated CLT a very robust construction method from a hydrothermal standpoint. On the other hand, if we flip the construction around so our insulation is internal to the CLT panel, the situation is a little different. Now there is more vapour resistance on the cold side, so the temperature in the construction drops down too quickly relative to the rate of moisture vapour escape. The moisture passing through the insulation is hitting the relatively cold inner surface of the CLT panel where it can condense. The more insulation we add, the colder that surface will become, as less heat from the internal environment will reach it. This reduced temperature will in turn make the condensation risk at this interface worse. In order to remedy this, we need to limit the quantity of vapour entering the construction, which on paper can be achieved by adding a vapour control membrane internally. This boosts the level of vapour resistance on the internal side, increasing the gap between the dew point and temperature and reducing the condensation risk. There is a complication with this approach, however. While a vapour control layer or a foil-faced insulation board with a similarly high vapour resistance will reduce the dew point, its as-built performance may not match its performance on paper. If the membrane is not sealed properly at laps and junctions, or is damaged either during installation or by following trades, it may allow more vapour through than it should, reintroducing the risk of condensation occurring. Increasing the vapour resistance like this also requires careful consideration of indoor air quality and the provision of fresh air to the living spaces. With this, too much vapour resistance can make internal spaces unpleasantly humid and in extreme cases even unhealthy. So while in other types of construction, such as timber frame wall panels, there may be other advantages that mitigate this problem. In a CLT construction, it's far easier to place all the thermal resistance externally and keep this vapour resistance as low as possible throughout. This breathing wall type of construction helps ensure very highly insulated building envelopes can both limit the extent to which powered ventilation is necessary and have flexibility in the specification of insulation materials. This is important in more ecologically focused design, where materials such as hemp bats or recycled fibre products typically have very high levels of vapour permeability and may require a lot of depth to meet U-value requirements. An advantage of this approach is that air barriers such as our Wrap-Tite can be used externally on the CLT panel, with all service runs positioned internally. This provides a very robust airtight layer with minimal penetrations, ensuring the low air leakage rates required by passive or near passive standard buildings can be reliably met. In this case, we'll consider a solid sandstone wall, common to many older properties. Sandstone is a relatively soft sedimentary rock, which means walls built of sandstone can be particularly sensitive to hydrothermal effects such as moisture absorption and freeze-thaw cycling. This means that in addition to considering the flow of moisture through the construction and any condensation risks, we must also consider the capacity of the stonework to retain and store moisture. In this case, we can use the same analysis tool that we use for the CLT panel, a method defined in BS EN ISO 13788 and known as the Glaser method to obtain a basic view of the condensation risks at the interfaces. Once again, this will show us that a higher vapour resistance on the cold side will lead to an increased risk of condensation, and the higher levels of insulation internally can exaggerate this effect. As before, we can reduce the risk of condensation by placing the insulation externally and keeping the stonework warm. But in historic properties, this approach may not always be possible or practical due to conservation considerations or external features like gutters, downpipes and overhangs. There is, however, an important limitation to the Glaser assessment that we should consider, particularly if dealing with sensitive historic materials such as lime-based plasters and renders. The Glaser method considers the moisture flow only under steady-state conditions and does not account for the capacity of material to retain moisture in liquid form. This means that any wetting-drying effects to both the indoor and outdoor environments are ignored. The effects of weather such as driving rain being absorbed are also not taken into account. Fortunately, however, there is another calculation method we can use that will account for these effects, and this is outlined in EN 15026, Hydrothermal Performance of Building Components and Building Elements, Assessment of Moisture Transfer by Numerical Simulation. This standard, which allows for the dynamic assessment of moisture movement, including weather and moisture accumulation effects, is specified in the BS 5250 Code of Practice for assessing the hydrothermal performance of solid walls. So if we now take another look at our internal wall using this method, the results become a little more nuanced. The internal insulation case, where a permeable insulation like our Spacetherm aerogel is used, can show a higher degree of condensation risk under the Glaser method. But if we include moisture storage and inward drying in our assessment, this moisture accumulation can be accommodated in the fabric until conditions are more conducive to drying. This effect also means that the overall moisture risk can, counterintuitively, be at its lowest when vapour control layers are emitted. If we flip the insulation around to the outside again, while this still poses a lower overall condensation risk, we still have to ensure the stone of the wall can dry out effectively and that the passage of moisture vapour is not disrupted. Many older properties are finely balanced systems, where the balance of heat and moisture transfer has remained more or less for many years. Adding modern materials and applying modern performance standards can therefore disrupt this balance and can cause damage to the existing fabric. Lime-based plasters and renders are particularly prone to this type of problem, as lime is significantly more permeable than most modern mortars. If the retrofit work is not well considered and the moisture content in the stonework changes dramatically, it can cause a variety of problems. If the moisture content goes to high, this can result in damp problems arising internally, or the expansion caused by freeze-thaw cycles can cause cracking and spalling externally. Conversely, if the structure dries out too much relative to its historical baseline, materials can shrink or become too brittle, again leading to cracking and deterioration of the building fabric over long term. The 15026 assessment not only allows the full range of performance characteristics and environmental effects to be incorporated into the model, but it also allows this to be run for extended time periods. This allows the identification of small problems that may increase year on year to grow into larger ones over many years. This detailed knowledge allows designers to ensure retrofit work is sympathetic not only to the aesthetics, but also the hydrothermal characteristics. Therefore, we can ensure upgrade work is sustainable not only in terms of environmental impact, but also in terms of long-term robustness and durability. It allows the energy performance improvements to be maximised, whilst limiting the scope for long-term problems to arise with either the building fabric or the health of the occupants. Whatever construction methods are used, and whatever the development type, the key consideration in designing for net zero is ensuring that the building fabric and systems are suitable. Simply taking existing designs and increasing the levels of insulation and airtightness will not always provide the optimum result. The simplest and most effective solutions are those which consider not only the fine-tuning and optimization of the building fabric, but also those which take into account the wider social context in which those buildings are used. New ways of thinking about how we interact with the built environment will likely prove just as important as fitting new technologies into existing practices. And we'll now move on to the Q&A session.
Good morning, everyone. Welcome to our live Q&A session. For our regular viewers, I hope you have had a nice summer. And for any new viewers, welcome. My name is Carol Mikulak, and I'm delighted that you have decided to stay with us today. I hope everyone enjoyed today's presentation. As always, we will stay on here and answer any questions that you may have. So feel free to drop any questions into the YouTube feed, or alternatively, you can send us a direct message to our Twitter page at Proctor Group, or email to webinar@proctorgroup.com. If you do have to leave before we finish, or you think of something after you have left, don't worry. Please just get in touch by any of the usual means, leave some contact details, and we will get back to you as soon as we can. If you have registered for today's webinar, and there is still time to do so, you will get a follow-up email from us with a link in there allowing you to watch back the full presentation and this Q&A session. Please feel free to forward that on to anyone that you think might find it interesting. There will also be details in that email how you can request your own personalised CPD certificate. Please also, if you can, leave us some feedback, and if possible, subscribe to our YouTube channel, where you will get updates on things that we are involved in, as well as details on future webinars. Now, if you'd like to discuss anything at all that we cover today in more detail, see some product samples, or arrange a meeting with one of the team, please just get in touch. We are always happy to chat, see what you're working on, and help in any way that we can. You can also, as Kira mentioned at the start of the presentation, revisit any of our previous webinars, both from earlier this year and last year. And these can be accessed either from our YouTube channel or from the Learning Hub page on our website, www.proctorgroup.com. Now that the summer break is more or less over, we are moving back to fortnightly presentations. So our next webinar will be Friday the 10th of September at the usual time of 10 a.m. And we will be revisiting a previous topic, being physics and applications of construction membranes. So if you missed that one back at the start of the year, or you'd like to come join us again with some different questions, please join us back here in 2 weeks. Registration for that webinar is now open. Okay, so let's move on to our Q&A session, and let me introduce you to our panel of experts. With me today, we have our National Sales Manager, John Johnston. Good morning, John.
Morning, Carol. Morning, people. Hope you enjoyed the seminar.
Next, we have one of our Regional Technical Managers, Adam Salt. Good morning, Adam.
Good morning, Carol. Good morning, everyone.
Next, we have Sue Menmuir, who is one of our Technical Advisors. Good morning, Sue.
Morning.
And finally, our very special guest on the panel today, who gave us a really interesting presentation earlier, David Somervell, the Secretary of Cohousing in Southern Scotland and Advisor on Sustainable Architecture. Good morning, David. It is wonderful to have you with us today.
Great, and me too.
Fabulous. Now, I can see a few questions on the YouTube feed already, which is absolutely great. As always, please keep them coming, and just bear with me as I'm collating them in from various different sources. So let's start. David, if I could come to you with as our very special guest for today. This one's come in on the YouTube feed from Caroline May. Do you think the recent relaxations of planning in England and Wales might inadvertently assist in the emergence of new models for community-led development?
So it's unusual, being a Scot now, for me to look south enviously. 5 years ago, the Treasury allocated 200 or more million pounds for a coalition of co-housing UK network and others called community-led housing, and they allocated a substantial amount of money to enable innovation and support for community-led organisations wishing to establish small housing schemes on the edge of their village or whatever, where there's a housing need. We don't have that in Scotland at the moment. So it is an ironic potential co-product of the proposed planning changes in England. But I'm afraid that those planning changes, which are generally tearing up the rules, are probably not actually a very good idea. And what we need to do is to look to the continent to see where it's possible to have planning-led initiatives where you can get a balanced community established, not just endless housing, together with opportunities for innovation for self and custom building.
Fabulous, thank you. We actually had an early comment come on the YouTube feed. I'm not sure, David, if you might be able to help with us. Paul Handfield said, I hope you used the underground stream commented for a water source heat pump. That might be something that they can do a little bit more digging in to find out if you're not sure with that one.
So I should bring friends up to date, really. We had the most absolute roller coaster of a coming together of complete strangers, mostly. A few of us knew each other in bringing together the proposals for this. We gained a lot of community support from the neighbours in the surrounding housing, and they could see that there was a benefit in this mixed mode, this in-between private and public housing, where a housing cooperative would have been established. We had 135 signatures just in 10 days from neighbours, and 42 separate emails begging the convener of the Finance and Resources Committee to permit this community group to be identified as preferred bidder. And we made bids in mid-June, along with others, because it was a closing date was set, and sealed bids. And we put in the group put in a bid for £1 million for this property. Others put in more, and we were 5th out of 14 in the ranking. When it came down to it, unfortunately, despite as a public body, the opportunity for every public organisation to take best value into consideration, not just the economic, but the social and the environmental and other benefits that might accrue. Unfortunately, they voted to award the preferred bidder status to a developer, a small private company which is going to build 6 houses for a private sale. They'll probably sell at £695,000, way out of league for most people. And it'll be almost a gated community. So it's a real shame. We were totally gutted. But of course, in the group of people, of young families and older people and retired people, there's an energy engineer, and she was absolutely desperate to tap into the stream underground. But if we had built to passive house standards, we almost need no heating system. And so this is the big change in retrofitting or building new now, is that we need to move away from thinking that we've got to have the white box on the wall, a heating system.
Yeah, absolutely. Okay, let's move on. Another question on YouTube. Sue, if I could bring this one to you. Peter McDonald, who I think has been a guest a couple of times, what would be the advantage of using space therm in a co-housing project?
Okay, right, well, obviously space therm is it's a thin, very highly thermally efficient insulation material. Obviously in co-housing projects, the actual residences may tend to be a bit smaller than you would in a like a traditional like residential build, for example. So compared to using a more traditional type insulation where you would need a greater thickness, by using space therm, you're not encroaching into the room space, and therefore your actual footprint of your building it remains obviously slightly larger. So that is one of the main advantages in this type of application.
Perfect, thank you, Sue. Okay, Adam, if I can come to you with the next question we have on YouTube from Donna Sterling. Donna says, if I am using Raptite on my walls, how do I detail the Raptite to the roof, creating a continuous airtight line?
Okay, yeah, that's a good question actually, because when you think of Raptite these days, it's mainly known in the industry as a wall membrane used on the wall applications. That'll probably actually come from all the sort of high-rise projects we see it on, and all the sort of marketing we do with our big high-rise projects and timber frame panels. That's where it's most commonly used on. Now with high-rise, typically we have flat roofs on high-rise projects. So the detail for the Raptite of a flat roof will be Raptite of the sheathing board on the walls, then it goes over the parapet, carried down the sheathing board, and then lapped under the VCL, and that's your continued airtight line for a flat roof. Obviously some slight details depending on your project, variations, but that's the typical sort of detail. Now in pitched roof design, however, you can actually use Raptite to go over the pitched roof as long as it's fully supported. So for a wall, the membrane must be class W2 water holdout. And for a pitched roof, you need a class W1 water holdout, which Raptite is. So there's no issues there with continuing Raptite from the wall onto the roof. And then by using Raptite on the roofs and the walls, actually makes it simpler for achieving that full airtight envelope. I think we've mentioned in numerous other webinars, such as the self-build one. I've worked on a couple of projects where Raptite's been used on both the walls and the pitched roof membrane. So go check out the self-build webinar as well, where we discuss that one in a bit more detail. But yeah, thank you, Carol.
Thank you. Okay, John, let's give one to you here. Marina Phillips has put a question on YouTube, and James Sinclair's put an interest in the answer as well. Can wrap type be used to stop drafts at floor edge details in existing housing stock with timber floors? We are trying to reduce air leakage and improve thermal efficiency.
Yes, it's another good question. Yeah, the wrap type product comes in a 1.5 wide roll, but we can cut it up into various strips. So sample here of a 150 millimeter strip. So that could be quite easily installed on the timber floor and then dressed up underneath the skirting board before you put your floor covering down. So it can be used in that application. It could also be taken straight across the floor. So if you have a timber floor with timber boarding and you've got a lot of drafts coming through that, then this will eliminate the drafts and keep your warm air into the building and stop any condensation issues. So it's a great application for that in new and refurbishment.
Perfect, thanks, John. David, if I could come back to you with another question here on YouTube from Andrew Travers. How can an architect like myself get involved in co-housing projects? Very interested.
So I think it was at a Scottish Ecological Design Association supported, what was it called? Festival of Architecture in 2016 that CHOISS really formed. There'd been some murblings in previous years, but it was a public talk by Maria Brenton, who was one of the co-founders of the Older Women's Co-Housing, which I featured. Lots of people came to that, and it's been quite interesting to see how this has grown slowly over the while. There's now about 450 people on a mailing list in this expanded to Cohousing Scotland, and there are several architects lurking on that list. And of course, as we had interested, BBC had a feature on this, the Comiston project. As that grew, then 2 or 3 other architects said, when you go to stage 2, because we obviously, Richard Atkins had done an amazing job of introducing a sketch scheme of feasibility. But obviously there would be much more detailed planning if we had been identified as a preferred bidder. And we would have gone out and invited a number of architects to share their ideas with us and selected one. So I've put into the chat an email address for info@cohousing.scot, which is a network which, as a sort of younger sister, if you like, a new sister for the UK co-housing network. So that's how you can explore. But as I said, there's an enormous amount of good advice on this. We even had architects, a young architect in her 20s who made the website, but she actually did understand the importance of keeping a professional life away from personal life, and wasn't trying to do the architecture. You have to be quite careful in these things when it's to do with how we're relying on each other.
Perfect, thank you. David, whilst I've got you, I've got an email come in here from Joseph in Colchester, right, a good one for you. A number of co-housing projects are based on a hybrid new build and refurb model. Are there any inherent advantages? Put my teeth in this morning. Are there any inherent advantages in that approach?
So yes, Cannock Mill in Colchester itself, where the mill building, a lovely clapboard, timber-clad building, is the common house where dining rooms and so on are, is a good example. I think it's very, very dependent on the site, the location, and so on. We were being opportunistic in advocating that this was a community-led initiative in this example in Edinburgh, and we were trying to find a way to evidence that there would be more than the benefit just of the co-housing community itself, less hospital admissions, a whole range of different social and psychosocial benefits that accrue, reduced loneliness, isolation, and so on. But we were also bidding and showing how it could be useful for neighbours. They could come and mend their bikes or whatever it is, or use the electric city car club car, which would be parked in front of the house. Now, these are all things which are co-benefits, which are very difficult to compute. And the Finance Committee found it too difficult to compute, unfortunately. The main problem for innovation in housing at the moment is the hegemony of the big 6 house builders in Britain, who've got all the land banks and everything, and also a government, say in Scotland, who's relying on them to deliver the very high targets, 100,000, now 110,000 affordable houses by 2032 in Scotland. So there's a recognition of this being a challenge, and I think in many, I showed different examples where you got a big house and so on. In the case of Your Space, the York-based co-housing, their first project which they bid for was a building, an existing office building, which the City Council was disposing of, which they were proposing to convert into accommodation. So it could be, there's all sorts of things. That's not it. It's the people, it's the self-determination that's the important thing, which is unusual in Britain.
Perfect. Thank you so much, David. Okay, let's move on to another email I have. Sue, if I could bring this one to you. Louise in Stockport has emailed saying, airtightness is very important to us when looking at the design for the housing. What options can you provide?
Okay, well, the degree of airtightness achievable will depend on all aspects of the construction, as well as the workmanship involved as well. So traditional methods of providing that airtightness line is to use a vapour control layer internally. We've got obviously several membranes ranging from a low emissivity vapour control layer to a Passive House approved variable performing membrane, which is our ProCheck Adapt. We also then have our wrap type membrane, which you've heard about, which is a self-adhesive breathable airtight membrane, which is designed to be used on the external of the building. So that moves your airtightness line outside, which helps to avoid all the awkward penetrations like your joists, your services, etc. So by simply moving it externally, you don't really have to, sort of like detail around those areas. Wrap tight is also Passive House approved and is capable of achieving airtightness levels of below 0.
Perfect. Thank you, Sue. Okay, Adam, let's move back to you with this next one. We have a message on Twitter from Crazy Cat, I think it is. We are currently looking at making changes in our lives towards net zero. How important is it to evaluate the performance of our properties on this path to net zero?
That's very good there. Commend you on that one. First of all, just like to say David's link is posted on the YouTube chat, the one that he was talking about in his answer a minute ago. But yeah, net zero, well, that's a good one because, I mean, there's lots of things we can do in our lives at the moment, from what we eat to the way we travel. But yeah, the house, the properties we live in is actually very important. One of the biggest contributor to greenhouse emissions is heating. And a big proportion of that energy as a result, coming from our properties. So there's actually a number of things you can do to reduce your carbon emissions throughout your property. Some of them are small changes, like going around and draft proofing your home, which I think JJ mentioned earlier a little bit in one of his answers. Areas where you're going to potentially lose heat, so might be gaps, windows, check around there where you can feel sort of air coming in and draft proofing those. Floorboards, chimneys as well, also quite common. So draft proofing can be fairly cost effective. Our wrap type tape actually is a great product for draft proofing. In the past, we used to use newspaper shoved behind our skirting boards, which is good for draft proofing, but it does get sort of mold build up, whereas Wrap Tight is not only airtight, it's vapor permeable, so it will stop any mold growth. So a good product to use for draft proofing. But heat can escape through any part of the property. So to prevent that, we use insulation. As mentioned in the webinar and previous webinars, you need to make sure you've got the right balance, depending on your property, between heat and moisture management. So that depends on your structure, the type of insulation you use, whether it's a solid wall, etc., etc., which we can assist with. You can also look at the heating system itself. As David mentioned, maybe not even consider the heating system. But typically heating systems run on gas and oil. So potentially replacing that with something more renewable and more energy efficient. That could also be a good thing. So lots you can do on your properties, and probably give you loads of ideas, but yeah, definitely things you can do.
Thanks, Adam. If I could just stay with you, Adam, a question came in on YouTube from another question from Andrew Travers. Can someone help with the EN 15026 method of assessment? Is that something you can guide him with? Okay, so the EN 15026 method is the hydrothermal assessment method. We have a WFI software, which has been mentioned a number of times in, again, previous webinars. But yeah, that's our hydrothermal assessment method that uses the EN 15026. So technical, the likes of Sue can run WFI calcs. We'll need a bit of info on your project, your build-ups. So again, getting contact, site location, and things like that, and we can assist with that, certainly. Perfect, thank you so much. Okay, John, if I could come to you with this next one. Another email in about airtightness from Xander in Portsmouth. Airtightness is very hard to achieve when trades constantly puncture the internal air barrier. Can you overcome this with any of your products?
Yeah, that's a common one that we do come across quite a bit, especially the sales team when they're on site. If you're specifying the wrap type product on the outside, then that's your main air barrier. But depending on the insulation that you're using within the building, you may still require this internal air tightness layer. Sue mentioned earlier, we have a variety of these, from the basic sort of reinforced vapor control layers up to our reflective product. But they're only as good as the people that put them in and install them. We can give you all the technical information that you need, but if you put this on the internal side of a building as your vapor control layer, and the Sparky comes along and cuts a great big slice in it to pull a tiny little thin cable through, then you're not going to have an airtight layer. Contractors are getting better at that. They do understand now, more and more of them are understanding the benefits and why we need to keep these air barriers tight. So yeah, they do need to be sealed, and it's a learning curve on site, which our sales guys do quite often when they're out on site, giving installation guidelines and training on this. So yeah, it's a difficult one to make sure it is being done, but yeah, we've got lots of products and lots of advice that we can give you on that.
Perfect, thank you, John. Okay, David, can I come back to you with this next one? A message on Twitter from Ashif. What barriers are there to more widespread adoption of community-led models, and how can they be removed?
So I take the example of several countries in Northern Europe. Germany, for instance, requires public bodies not only to list their property that's surplus to requirements, but to put on a special website any surplus land, maybe a derelict clinic or whatever that the health services is no longer needing. And make that available at agricultural land values to community-led housing. Now, this is a different approach. In the case of Austria, there's over 60% of all dwellings are built in numbers of less than 6. So it's small house builders who are building the dwellings that are inevitably designed for the people. Now, that's the way that you can get communities actually coming together, intentional communities. In the case of Amsterdam, they've been the Dutch are so clever with the land reclamation. There's a whole new island been formed just beside Amsterdam. First of all of the land in Amsterdam is owned by the city council, and you lease it. So they've got retained control over the planning of it. But I met 2 years ago an official, a housing officer from Amsterdam, who was responsible for working with community groups to develop an intentional community for a whole part of that island. So there were people coming together, how do we want to do it? And then you get a much greater ownership of them, and everybody looking after that community, and you get the resources, the requirements, the little shop or whatever it is, or the small office, a home office type thing. All of these are different ways of approaching it. We've got a very market-based housing over here and industry over here, offices over here in Britain, which is very much opposed to the way that Patrick Geddes always talked about folk, work and place, and that we need to have the interrelationship between these.
Okay, thank you. So
it is happening a little bit in England, and there's a continuing small fund that's being made available for community-led groups. I'm hoping that we might be able to make the case for that in Scotland.
Fabulous. Just to let everybody know, there are a few things. Hopefully you can see the Zoom chat feed. David's been putting a few things in there as well. If there's anything that you're not sure on there, just come back to us and ask as well. Okay, Sue, if I can come back to you with this next one, another email from Natalie this time. What is more important to look at when designing a co-housing project? Thermal insulation or moisture control?
Ooh. Well, basically, I mean, like the HAM principles, which is heat, air, moisture movement, are all equally important in any design. In co-housing projects, obviously with smaller residences, you do generally tend to have larger communal buildings, such as kitchens, laundries, etc. So in these instances, you would look at the design individually for these different areas. So for example, if the laundry's not being carried out into the individual residences, the production of moisture is reduced in those buildings. So therefore, you might only require a lightweight membrane to control your moisture movement. In the larger specific areas where you are going to be carrying out either communal cooking or laundry, for example, you might need a more robust membrane that has slightly higher vapor resistance, for those areas. So you would consider the individual areas, consider the need for ventilation systems for all these individual areas, basically.
Perfect, thank you. Okay, Adam, I've just seen this one coming in, and I know this is one that you have a good bit of experience with. Robert Grant has emailed saying, have you worked on any passive house projects that we could know more information about?
Yeah, it's obviously very hard for me not to talk about one project, but we've worked on a number of them, especially now Raptite and our ProCheck Adapt membranes are both have their passive house certification, so they're actually ideal choices for these low energy types of homes. We also have our high performing insulation space firm on a number of projects. We've got a number of companies that use it as detailing, thermal bridging areas in particular. So yeah, it's used on a lot, and we've got a lot of case studies as well, so get in contact. But the main project I'm going to talk about, and I can't resist, is St Sidwell's Point. I recommend everyone sort of going away and doing a bit of online research about them. It's a project down in Exeter that's nearing on completion. It's the world's first passive house leisure centre that I've been working on for well over a year now. So on that, we've got our fire shield membrane, we've got our Raptite, and we've got our ProTech Adapt. So a number of different membranes. Now, St Sidwell's Point has really tough targets to achieve, not just going for passive house standard. They got a target of 0.2 air tightness. So that's the detailing is incredible on that project. So the benefits of having a sort of passive house leisure centre would be, big energy savings compared to a normal good practice leisure centre or swimming pool. Big reductions on the water use. You've got outstanding sort of internal water and air quality, excellent daylight levels. You've then got healthy and compromised uplifting indoor climate, lower maintenance costs, mainly due to the better building fabric that's been put together. So on this project with the wrap type, that's been steered onto a number of different facades within there. So we've got the CLT, the sheathing board, the block work, and this is the robust airtight line, or one of them within that build on that wall type. We've then had the fire shield, which is installed. So the rock wall goes onto the wrap type. Fire shield's gone on over the rock wall, and that offers fire performance, but also prevents wind washing as well, which seems to be which is a big thing with the passive house projects. And then finally, we've got our Profoil 861, which is used in swimming pool areas where you've got the high moisture loads, but also the aluminium facing, so that protects both sides of the membrane with corrosion, which you'll get quite a lot from chlorine within the swimming pools. So I could talk a lot about St Sidwell's Point, but I recommend doing a bit of research on it and going down and having a look, really. Yeah.
Perfect, thank you. We'll get the link for that one put up in the chat feed so everybody can have a wee look and see what that's all about. Okay, Sue, can I come back to you with another question we have on email from Trent? My building is a steel frame and I have cold bridging. How can I improve this?
Okay, so firstly, consider a warm frame construction or a hybrid construction where the insulation is placed externally, so therefore it keeps the entire structure warm and reduces the condensation risk and the effect of the cold bridging of those seals. It's always a good form of construction. For other areas, we've obviously got our cold bridge strips, our Space Therm cold bridge strips, they are manufactured using the Space Therm aerogel insulation. So they can be installed over any areas of steel, timber, for example, that is creating a cold bridge element. Other areas to consider would be things like your window reveals. Insulating them will actually make a dramatic difference, and will obviously won't contribute to, it will prevent your overall heat loss, reduce your overall heat loss.
Excellent, thank you, Sue. Okay, if we come back to the YouTube feed here, questioning, David, if I could put this one to you from M. There may not be a lot of data, but are maintenance contributions compared to buildings without highly thermally insulating glazing much less? Or is it mainly the fabric of the building? The reason I ask is that I'm noticing a lot of resistance to triple glazing from many glazing suppliers.
So in our current house, we've got a couple of Velux windows, which are in the coombs. We've had to replace the double glazing ones because they are very thermally stressed. And I am aware that, especially in some of these really sophisticated office buildings, we're talking mostly domestic here, although it's interesting to see this Exeter example. Most of them are quite sheltered and so on. And so you're not really pushing the boundaries of the technology. But I do think we need to be careful to design for repair, to design for replacement and so on. And so that clever detail, which is a glass box hanging out over, looks wonderful architecture, may not be the wisest thing. there are good reasons why some of the traditional details of having drips, of having overhangs and so on, to protect junctions and joints from inclement weather. The sun is absolutely killing. It's really, really the most powerful thing that nature is. And we need to respect it when we're designing buildings, and maybe not rely on gizmos too much. And that's where, in my point about the puncturing the membranes, if you design it so that you've got a services zone that's separate, then you're actually designing out the problem rather than trying to solve a problem of puncturing the membrane.
Okay, thank you very much. Sue, can I come back to you? A question here from Rory. Hopefully you can help him here. Is there definitive guidance on achieving net zero in housing?
Definitive guidance. I think that there is obviously guidance there. Various passive house, for example, it's not net zero, but there is guidance there. It might be something I would have to look into specifically and get back to Rory on.
Okay, perfect. Thank you very much, Sue. One just come in here from Paul Hadfield. Adam, if I could put that one to you, just going back to St Sidwell's. Paul says, St Sidwell's Point in Exeter looks like a lot of steel, aluminium and concrete. Was an attempt made to minimise the embodied carbon there?
Good question there, Paul. I would probably have to have a chat with the main contractors, the architects and the clients who have done a lot of work into this. So we've got Kier as the main contractor, Gale and Snowden's the architects, and I think Exeter City Council as the client. There has been a lot of work, I know, in sort of looking into that, but as to what, I wouldn't be able to answer. I can really sort of talk about our membranes on the project and where they fit into the design. With everything else, I'm not too sure.
No worries, perfect. Thanks, Adam. Okay, let's move on. I've actually only got a few more questions here that have come in on email. So if anybody still has anything they'd like to put in, please add it in now. John, can I come back to you with this one? We have had a message on Twitter from Smithers2. Can your wrap-tight product be used to help seal and protect modular housing units during transportation from the factory to the building site?
That's a very good question. Again, some really good questions coming in today. This is an area that we're spending a lot of time on developing. So, yeah, I mean, the product that provides this airtight layer, protecting the modular unit during transportation. It's well suited to our climate, as you know. We don't have nice sunny days every day, but during the winter, when a lot of these products are maybe being shipped from the south of England up to the north of Scotland, it can be very wet. There's a lot of spray comes off these roads, and high winds as well, which causes a lot of problems with membranes getting ripped. So a lot of these units, again, are more or less pre-finished inside. So the last thing you want is any moisture penetration. We have done some work with quite a few of the modular companies and putting the wrap-tight on, which, as we say, is self-adhesive. It's got a very good bond on the back of that. So once that's on, the building, the unit is completely sealed, then it's ideal for transportation to keep it wind and watertight.
Perfect. Thank you so much, John. Okay, David, can I come back to you with one here? It's an email from Sam. Is there a place for the common house principle in local authority like social housing developments?
So for social housing, it's called Housing Action Grant in Scotland. This is the grant from the state to overwhelmingly the residential social landlords or the housing associations who are doing most of the development of these, of the current wave of social housing, of housing for rent at reasonable amounts. At the moment, Housing Action Grant is only eligible for the dwellings themselves. And so this has been a challenge where co-housing groups have wished to develop for rent, but because Housing Action Grant is not applicable and not eligible for the common house. So I think that's a big challenge because it doesn't see things in the whole. It's just very much for the family or for that individual householder, and doesn't see the value of a holistic. And this is where the title of this thing is Building Net Zero Communities is an important thing to think about. And we need to think holistically about human needs through the lifetime, as I've pointed out in my presentation, from youth to old age. Lifetime homes is a really important principle, but lifetime communities, so that you don't have to move all the time, would also be something which would be a good principle. But at the moment, the way that in the UK the state subsidises and allocates capital resources doesn't permit it.
Okay, thank you so much. Now, actually, it's quite difficult for me to see the Zoom questions that are coming in, just the way with my setup is. But I see that David's actually put a question in that he would like the panel to look at as well. How would you approach the thermal upgrading of the Comiston farmhouse? Sandstone walls with lath and plaster internal lining. John, perhaps you would want to maybe comment a little bit more on that one.
Yeah, we've done quite a few of these projects, David, over the years, both with local authorities. We did a couple of projects with Angus Council, and we've also done some private dwellings. We tend to find a lot of these older houses where you've got nice cornicing. You don't want to interrupt the cornice. So there's really two methods of doing that. We have a variety of different layers that we laminate to the aerogel product, which can be installed and stuck direct to the existing plaster. Or you can take the actual space therm and sheet form, depending on if you've got lots of curves in the walls, and actually bond that to the walling, and then take a thin render or a line plaster fixing off the surface of that. We're also seeing a few specifications where people are putting in sort of like a hybrid wall. So they may put a traditional sort of insulation, insulated plasterboard or rock wool product so far up, and then take the aerogel, the thinner product, up to detail underneath the cornicing. And some are putting little lights on to highlight that up. So there's lots of different methods that we could advise you on that.
Just on that one, earlier this year was the thin internal wall insulation report, which our last webinar covered quite a lot. And it looked at a number of different types of insulations and taking into consideration not only the thermal improvement, but then the moisture management through that wall when you add the insulation, and also thickness as well, which I think aerogel and space firm sort of looks really good in that report. So if you want a bit more info, that webinar can also assist there.
We would also be able to look at the construction as well, using like our WIFI analysis, the hydrothermal method of calculation as well for the condensation risk.
So for me, you never ask a question that you don't know, or haven't got an idea of the answer. For myself, it's absolute unacceptable to most planners and everybody, lots of people. For me, I would put thermal insulation outside that sandstone building. There's no doubt in my mind that would be the best way. It's got big overhangs, over 400 millimeters of existing overhangs. You could fill nearly all of that with external insulation and then put a line render on the outside of that. Of course, then the question in my mind is which insulation you use for that. That's the question where I introduce this concept, which is awkward. And I hope proctors will be thinking about this, is the embodied energy in all the materials that we're using. I think by introducing probably lime rendering before putting the external insulation on would provide effectively a very good air movement barrier, then the question is what material you use externally. And that's why I mentioned Indie Nature as an example, which is capturing and has just been awarded a substantial circular economy grant to help build the factory by Selkirk, so that farmers in the borders will be growing hemp, and it'll be processed in Scotland, and it'll be and the bats and the boards that they will be producing will be available in Scotland. So that's the sort of question in my mind. And then you've got all the fabric internally warm.
Externally does make sense, especially from a design point of view. But in a lot of these type of projects, sometimes it can be difficult to go externally and to cover up some of the existing features. I used to live in Bath, and lots of lovely Georgian properties, and all needed firmly upgrading, and just external wasn't an option on those type of properties. But yeah, if it is an option, then from a detailing point of view, I think it is a much more sensible, but it just depends on types of projects with that.
Yeah, they're case-by-case projects that you need to look into, because a lot of these old buildings are listed and you can't do anything to the outside.
Yeah.
I've done a lot in Liverpool with brick facades on the front, where they can only put internal insulation into because of planning.
Yeah.
But it may be that we need to reimagine how buildings will look, and in the face of the climate and ecological emergency. So it may be that we need to welcome that yellow Harald, lovely warm lime wash that would have been on that as a different look for the next 60, 100 years, and so on. So we're often thinking very short term in all these things. It's just, let's dodge it up. But if we're able to look longer term and invest for the longer term, then our buildings won't need knocking down. They'll be enduring, like those Bath and the Edinburgh sandstone tenements, which could and should continue for another hundreds of years.
Okay, thank you very much. I'm just going to go quickly back to a question that I'd asked Sue earlier on about the definitive guidance on achieving net zero in housing. David, if I could just come back to you, because I noticed you'd put just a quick comment in the Zoom chat. I can't unfortunately bring that up. So do you want to just sort of revisit that and let everybody know what you'd sort of put a further comment on about that?
So I'm very conscious that made in Britain, designed in Britain, the natural ventilation thing which we've been holding on to with our slot ventilators in windows. Earlier in my career, I worked in Glasgow for 5 years with Heatwise Glasgow, and we were doing very, very, very simple energy conservation work in the big housing schemes around Glasgow. People living in fuel poverty, having to choose between heating and eating. That British way of doing things, it's damp in here, you've got black mold, keep the windows open, which was the mantra for many, many years, and still in a way is a problem. We need to maybe accept that this continental concept of mechanical ventilation with heat recovery might actually be a good way of doing things. And that actually reduces this anxiety about overmuch generation of water vapor within a dwelling, because actually the opposite might happen. You might actually get slightly too dry in a dwelling. Certainly when I was working at the University of Edinburgh, we had to introduce humidification in the new veterinary school at Easter Bush, because the ventilation system was quite high rates of ventilation because of laboratories and so on, actually meant that very low absolute moisture content, external air was being drawn in and warmed by outgoing air, energy efficient, but actually it meant that you were getting down into the low 30s of relative humidity uncomfortable for people's eyes, and so on, not healthy. So, but mechanical ventilation with heat recovery starts to find a balance, and that's where these passive house standards, we maybe need to swallow our pride in Britain and accept passive house as a suitable and sensible approach. I take issue sometimes with their excessive focus only on energy use, and no concern at all about the actual materials themselves being used. And so a lot of plastics materials, I think there's a potential danger of just wrapping everything in plastic. And so it's interesting, Sue's comments and others about relative permeability. But I do come from a school of thought, which is that actually you want to have as much permeability, vapor permeability as possible, and then to reduce the risk of saturation at any point.
Excellent. Okay. David, a question to you that's come in from Dave McGrath. If the Solum has air bricks and the void behind the lath is ventilated, would you still do EWI, external wall insulation? What would you do about the Solum air bricks?
Yes, this is really interesting. I mentioned what a transformation our Gillespie Crescent, a double upper flat was. The intermediate floor, the attic floor, if you like, that the top rooms were in. I remember the carpet flapping like this because the wind was coming through. And in the traditional construction, there's a lot of air pathways going through everything. Huge challenge. So you need to rethink that. And it might be that, as I said, you've got to, especially with a major intervention in a building like that, it might be that you need to move the theory from being suspended timber, dry floor, to a solid timber or solid floor, or some other approach which designed away that need to keep the underfloor area vented. Otherwise, you do need to take off the boards and actually provide some means of blocking the air pathway between things. I think that, however, by looking at mechanical ventilation with heat recovery, you're actually reducing the moisture burden, or the moisture production burden within the dwelling, and that starts reducing the risk. So it's case by case, as many of you have already said, case by case, that you need to look at and analyze it and to see what might be the best design approach, but to recognize that older buildings are very interconnected, even between dwelling, in a terrace, for instance, and that's a problem.
Yeah, absolutely. Okay, this I think might be our last question. Adam, if I could give this one to you to finish with. Charlotte in London has sent in an email. Now, I think this might be one we could be here a long time with, depending. With all the different membrane offerings you have, how do I pick the right one?
Good question. There's a lot of membranes. This is just a small sample of ours out there. So I'd say simple answer, come speak to us.
It's on the phone.
We've got the technical gurus such as Sue, Ian, Callum and Paul and Pam that can assist. We've also got a team of regional managers as well that are very clued up on technical, so they can help get the right membrane for your project. I mean, if we're thinking about the types of structures out there, some we've mentioned today, timber frame, masonry, we've got SIP panels now, so structural insulated panels, insulated concrete formwork, oak frame, cross-laminated timber in St. Sidor's Point, steel frames, even sometimes natural materials as well. So most of these types of structures we're all involved in and can add value to your projects, but it depends also what we're looking at trying to achieve from your project. So as mentioned a number of times, when we're looking at air tightness, wrap tight we believe is the suitable answer for the simplified method to achieving that low air leakage rate. But thermal performance, you know, we always think about insulation, but membranes can actually add thermal performance when we're looking at the reflective kind that I think John also demonstrated earlier. So you put in a membrane standard breather paper in there already, why not upgrade that to a reflective one with an air gap in front, and you've got thermal benefit there, improving your property even more from using a reflective membrane. So yeah, they'll enhance yours. We've then got fire performance, someone always to touch on, buildings, especially when they're in close boundary or proximity of another one. So we've got our fire shield, which I demonstrated earlier with St. Sidros Point. That can go external, and a great video on our website to also demonstrate fire shield use in fire. We've got our internally, we've then got ProCheck A2, an A2 fire rating, considered non-combustible, but that's also reflective. So if you have a cavity gap in front of that, you'll also get a thermal benefit as well. So a number of different products, a number of different requirements from project by project, and we'll try and get you the best solutions. And yeah, we'll go from there really. So get in contact for that.
Okay, thank you. Absolutely. As Adam said, please just get in touch. Come and speak to us if you just need some help on clarifying anything, or something that you read that you're not sure if it's suitable for what you're doing. There's not always a one size fits all. We can discuss things with you, go through your individual requirements and come up with a solution for you. Okay, I think that possibly has covered all the questions for today. If I have missed anything there just at the end, my apologies. We will go back through it all just to make sure everything's been covered. Thank you so much to our amazing team behind the scenes for creating another fantastic presentation, and for all the support they give us before and during this live feed. A fabulous panel with me again today, I'm sure you can agree to. And a very special thank you to David for taking the time out to join us on the panel today. Now, we are actually repaying the favour of sorts on Wednesday, the 8th of September at 6 p.m, where Pamela Howitt, our Senior Technical Advisor, will be in a Q&A session with Mike Wilson from Cohousing Scotland. And they will be discussing latest options for keeping buildings warm, dry, airtight and healthy. If you'd like to register for that, tickets and registration can be found on Eventbrite by searching for Achieving Fabric First Insulation for Net Zero Homes. As always, huge thank you to you for joining us. If there's anything at all that you would still like to ask, hasn't been covered, or if you would benefit from a one-to-one discussion with us directly, please just get in touch and one of the team will get back to you straight away. Register now for our next webinar, which is the revisit to Physics and Applications for Construction Membranes, taking place in 2 weeks' time. Don't forget to give us some feedback, leave us a thumbs up and subscribe to our YouTube channel. So from all of us here in front of the camera and behind the scenes, thank you again for joining us. Have an absolutely wonderful bank holiday weekend. I hope the weather wherever you are is as gorgeous as it has been up here in Scotland this week. Take care and look after each other. Goodbye.